much anything we dump into a heap that will vary randomly, such as a pile of gravel or a pile of marble, will form a shape that is roughly normal. This shape isn't perfectly normal, but it's roughly normal. Most of the marbles are near the mean at the center of the heap. The mean is that center point in the heap. Right now we're not attaching any numbers to it, but the mean is somewhere around there, near the middle. Now, the point in the heap, essentially about halfway down the mountain, but technically at the inflection point, that's one standard deviation away from the mean. By away, I mean that line I just drew, the yellow line. The purple line is one standard deviation above, to the place where the curve turns in curvature. So that tells you the span between the left blue line and the right blue line. 68% of the marbles will be between those two blue lines, between -1 standard deviation below the mean and +1 standard deviation above the mean. 68% of the marbles will be in there if I've gotten the standard deviation in the correct location. Remember, the line at the center, the red line, is the mean. The green line that's now appearing is the 68% of the area is under the curve. It also means 68% of the marbles are there, and there's a 68% chance of a marble being in that range. Split that 68% in half and you get 34%. That is, there's 34% in that little chunk between the left one standard deviation below the mean, and there's 34% from the mean up one standard deviation, and together those make 68% of the marbles. That's true for any normal curve, and we'll see that a little later on. So that tells you that 68% are in the middle, and we'll worry about what's in the edges a little later, but if you subtract 68%, you've got to account for another 32% in the left and the right tail. I'm now going to use Desmos to show you a normal curve and how this works when we look at it more mathematically. I'm setting the mean to be 0. I'm setting the standard deviation to be 1 using Desmos, a graphing calculator. And I'm going to set the, initially, this is from -1, 1 standard deviation below the mean. This is what's called a standard normal curve. And here, 1 standard from the mean up 1 standard deviation. Look at that 0.34. That's the 34%. You might notice it's not exact. And if I go from -1 standard deviation to +1, I get the 68% of the area is visible there. That 0.682689 number, that's the 68%. In fact, with this I can calculate any of the areas under the curve, from -infinity to infinity, from -infinity to -1. Only 15%, 15.8 out in that piece on the left tail there. From -2 to 2, by the way, about 0.9544997, a little over 95% of the area is between -2 standard deviation and +2 standard deviations above the mean. Here again, I'm working with the standard normal curve. Notice that tiny bit of tail beyond -2 to the left, it's only about 2% of the area. And on the right, there's only about 2% of the area out beyond 2 standard deviations. So this is both the probability of a data point appearing in that area. Half of the data is above the mean. You saw that there briefly. 34% of the data is in this area. It also means there's a 34% probability that data will appear in that area. And this is true for anything that varies randomly. You get these heap-like histograms, these heap-like distributions. Now, here I'm setting up a normal distribution with a mean of 5 and a standard deviation of 2. You'll see it's been moved over. It's not a standard normal curve. And I'll make some adjustments here. From the 3 to 7, that's -1 standard deviation to +1 standard deviation, 68% of the area is there. I've changed the mean and the standard deviation, but as long as I go from down 1 standard deviation to up 1 standard deviation, I get 68% of the area. You can see that still. From 3 to 7, because now on that right curve, the standard deviation is now 2. I set it to be 2. The red is my standard normal that I started with for reference. And just for fun, let's add in one more, a standard deviation here, a normal distribution with a mean of 5 and a standard deviation of 0.5. That's a smaller standard deviation, 0.5. And I've got to delete the equals there. You'll see that in a moment. The equal sign is blocking this from functioning correctly. It's just a normal function. But always you can click on the asterisk and get help, and this tells me it. And there it is. Notice, because the standard deviation is smaller, it's taller and narrower. Now I'm going to go through an exercise where I'll modify these to use variables so I can see this a little better. Here I'm going to replace my standard deviation with the letter S. Now the standard deviation is something I can change with that slider, and you'll see as I change the standard deviation, as it gets smaller, the curve gets narrower. As it gets bigger, the curve actually gets flatter. I'm going to adjust the range over which this goes so it behaves a little bit better on my graph. And so now it's going to go from 0.1 to 10. There's 0.1, a very small standard deviation. As I go up towards 10, it flattens out. So that green line, I'm changing the standard deviation on that green line. And those are all normal curves. Now I'm going to go from, I'll initially make a small mistake here. I'm going from negative S to S. That's not right. It's the mean minus 1 standard deviation, the mean plus 1 standard deviation. And you can see it's not working because I didn't include the mean in my formula. So I have to go back and put the mean in my formula. So here I'll put the mean in. The mean is currently a 5. I put 5 minus 1 standard deviation, 5 plus 1 standard deviation. There's the 0.68. It's 68%. But watch this. Even as the shape changes, the area stays 0.68. It's always 0.68, no matter what the standard deviation is. That S, that's the standard deviation. It's changing. But the area is staying the same. The area shrinks and expands to always be 68% from the left inflection to the right inflection. The point where it changes from a frowny face curve to a smiley face curve. That's the inflection. Now I'm going to make the mean change by changing the mean to the letter M. So now I can change the mean and the standard deviation. So now I'll slide. When you change the mean, you just slide the curve left and right. But look at that 0.68 from minus 1 standard deviation to plus 1. The mean minus 1, the mean plus 1. That's the M minus S, M plus S. The mean minus 1 standard deviation, the mean plus 1 standard deviation. It stays 68% no matter where I put it. And if I go from the mean minus 2 standard deviations to the mean plus 2 standard deviations, I get 95, 44, etc., etc. Lots of decimals. And it stays the same no matter what I do, as long as I go from minus 2 standard deviations below the mean to plus 2 standard deviations above the mean. So these are things we can look up in a table or a drawing and use for any normal curve, no matter how narrow or how tall or how wide.